Okay, so let's get into why we should utilize NumPy arrays. Well, we have to go back to the list here because so far we have seen lists. We've seen the ability, Python affords us the ability to be able to store a mixture of data types within our list. We're not restricted to only storing integers. We can have integers with strings, with booleans, with other objects of classes, all within the same list. That's all good and well, but the problem is at the back end, where the memory is, well, they're actually located in different memory areas. They might not be consecutive to one another. So the list actually has to maintain pointers, as we see in the diagram here, to where exactly within memory this data is located. And of course, that point, the actual ability to have pointers in the first place, is additional memory because we have to have a storage area which its value is a memory address to another storage area in memory which holds the data we're actually looking for. So we actually increase the size in memory of having a list. Because those memory addresses need to be stored somewhere for us to be able to retrieve the data that we're pointing to. Okay, so it's all good and well being able to mix up our types, good for that flexibility, but of course that has an overhead of extra memory being utilized, okay, in a list. So in contrast, the traditional array, for example, which it only allows us to store data of the same type. Here we see integers represented, but in a traditional language you would specify what type of data because you'd actually instruct the compiler to allocate enough memory for, say, 8 integers. You would say that we want to create an array of 8 elements, so we'd say 8 times the size of an integer. If that's a 32-bit integer, that's 4 bytes, so it would be 8 times 4 bytes. 32. We need 32 bytes available for each of our different data, different integer values that we want to store. So with an array, that data is actually allocated in the same area. We call this contiguous. Contiguous, similar to consecutive. Elements that are in the same location as one another. And the reason why this is done is because the array name itself is often a reference to the first element of that block. And then if one knows the memory address to that, we can do pointer arithmetic, because if we know that integer, standard 32-bit integer is 4 bytes, then we know that all the memory addresses will be 4 bytes apart. So we can actually just increase the first reference by 4 bytes to get to the next storage area. So we can actually iterate over the entire array in a much more efficient fashion. We only have to store one of those memory addresses, the first one, which is typically the array name in your traditional languages, as opposed to the lists, coming back to that, where we have to maintain pointers for every single element because they're not in the same area. They could be all over the place, and we have to have the pointer to them. And of course, the actual types themselves will differ, won't they? Because we see here that a string in this diagram could potentially be 55 bytes, whereas with other data types, they could be completely different. So there's certainly an advantage to restricting the type of data that's being stored, because then it allows you to be more efficient at the back end. You can allocate memory in the same area with contiguous memory locations.